which is very close to everyone. We all suffer from traffic in cities. It has economic costs, stress costs, environmental costs, and some of us might say, well, I don't really care about traffic because I bike, but if you breathe in a city or if you breathe in our planet, then you should worry about all the pollution which is created not only by mobility but by the inefficiency of traffic jams. And not only that, worldwide more than 1 million people die every year because of traffic accidents. And the main cause of these accidents, it's the human factor, what is called the 4Ds, people driving distracted, drowsy, drunken, or drugged. And in this context, autonomous cars bring a great promise of making traffic much more efficient, reducing the time we spend in traffic jams, and also making more efficient and certainly reducing the death toll taken by traffic. And most companies and research teams have focused on developing algorithms and mechanisms for individual cars. Imagine in cities where you have 5 or more million cars, and you need to regulate all possible interactions, and if you have a communication failure, then it's not only it's not efficient, it's not possible. So what we have been working in our self-organizing systems lab is to take a different approach. Instead of trying to tell each and every element what to do, let the elements decide. So we take inspiration in natural systems like this starling flock, where there's no leader. Every individual takes their own decision based on local information. So in a similar way, we can let autonomous vehicles and also autonomous intersections take their own decisions based on their local information. And in this way, we are not only leveraging the complexity of the regulation of this highly complex system, but we are also increasing the adaptability and the efficiency of regulating traffic. And let me tell you a bit about our previous work where we were applying these ideas to regulating traffic light. In most cities, we try to match the speed of we try to match the synchronization of the traffic light to the speed of the cars, but this is not possible to do in all directions, and it also varies with the traffic density, with how many cars on the road. So here on the left side, you see a simulation which leads to a traffic jam of a traditional traffic light coordination, and for the same number of cars, you can see here self-organizing traffic lights, which maintain not only a constant flow, but actually a maximum flow, so they're optimal for this number of vehicles. And the way in which this is achieved is using sensors which detect how many vehicles are approaching each direction and simply giving preference to the streets with highest demand. So we took these ideas and implemented an open source simulator which is available at GitHub at this website, webpage, and we developed a model for autonomous vehicles. And here the main difference is that the acceleration and reaction time are immediate. If you have a human driver, there's some reaction time which you have to consider, because if the car in front starts moving, then you have few milliseconds before the human driver reacts, and we assume that autonomous vehicles can do this almost instantly. So in this simulation for low densities, you can see that autonomous vehicles with self-organizing traffic lights almost don't stop. They just have to stop when there are other vehicles crossing the intersection. So it's highly efficient. And let me show you just another simulation for a higher density. Here, cars have to stop just because there's a high number of them, but still you have always vehicles crossing all intersections, so here the limitation is not so much because of the traffic or because of the reaction time, but simply because of the infrastructure. And certainly, many people have noticed that if there are autonomous vehicles, then you could also leverage public and private transport and increase car sharing and services like Uber on autonomous vehicles. So let me explain you some of these results for autonomous vehicles. First, for the traditional green wave methods, here we are basically measuring the flow across the city. The flow is basically how many cars can go through the system. And if you have autonomous vehicles, you can avoid these traffic jams until very high densities. This is because autonomous vehicles will not block intersection. Still, you can see that if you have few cars, there's no improvement if you have autonomous vehicles. It is the same flow. And here we have human drivers, but with self-organizing traffic lights. And this configuration is actually better than having traditional traffic lights and autonomous vehicles. This means that if we had to choose on one technology, we can see that the adaptive traffic lights, which regulate interactions of vehicles at that scale, has a greater impact than having autonomous vehicles themselves, which in this case have faster reaction times. Because even if you have a fast reaction time, but every now and then you have to stop because there's inefficient coordination, then you will not be so efficient. However, if we combine both technologies, which is this blue curve here, you combine also the improvements, so you get even a higher flow if you have self-organizing traffic lights and autonomous vehicles. So the potential benefits are manifold in terms of efficiency. Other experiments we have done is, once we have autonomous vehicles in the market, which should be in 10 to 15 years, we will not have immediately all the cars being autonomous. In the United States, it's estimated that it will take about 30 years to replace the whole fleet, assuming that all the cars being sold become autonomous. Then we wanted to know what's the benefit of having a gradual increase of autonomous cars in a city. And we found this was interesting because it depends on the density, the impact of autonomous cars. If you have low densities, the impact is relatively quick. If you have few autonomous vehicles, they already have an impact. But if you have high densities, which is what occurs in many cities, you need to have a majority of autonomous cars in order to see a relevant impact. And this is some work which has been made at the Sensible City Lab at the Massachusetts Institute of Technology, where I was doing a sabbatical year, which just finished, which takes the perspective of also autonomous vehicles and a single intersection. If all vehicles are autonomous, then you don't really need to wait for a traffic light. You can regulate the cars as they approach the intersection. So instead of controlling just at the intersection, you can control it on the whole block behind. So the increase of efficiency is considerable, and we are working now on how to scale this work, which is for a single intersection, for multiple intersections. So in this way, we will be able to coordinate autonomous vehicles not only at the intersection, but exploiting the whole street behind them. So in principle, cars wouldn't need to stop. Of course, depends on the density. So it's clear that this is a revolutionary technology. Because of that, it will affect in ways which we still cannot predict all our lifestyles. And even when we have this lack of predictability, meaning that we still don't have idea of what would be the best business model for commercializing this technology, how will we interact with this technology? Precisely, I'm confident that we will find the best possible way, and I believe that this technology will bring great benefit to our societies and our cities. Thank you.